Hello and welcome to my lesson today, in which case I'm going to give you an introduction to integration. In subsequent lessons, we're going to look at definite and definite integrals, area under curve, and application to kinematics. But in this particular lesson, I will take you through the first objective there, which is a definition. And so let's begin with the definition of integration. To define integration, I'm going to say the following. First, integration is a reverse of differentiation. You are already familiar with differentiation at this step, therefore you know what I'm talking about. Integration is just the opposite operation of differentiation. The same way plus is a reverse of minus, and they're exactly reverse of one another in that particular manner. Integrating a function means, or involves, finding a function for the given gradient. Sorry, let me say it this way. Integrating a function, that function normally is a gradient, and therefore it involves finding the function from which this particular gradient is obtained from. For the function, say y is equals to 3x squared, the change in y over change in x, which is the first derivative, would be 6x. Now, if we were given the 6x, that is change in y over change in x, we are told that is a gradient. 6x is a gradient of some function, that is 6x is change in y over change in x of something. Then finding y, looking for the value of y, would be integrating 6x with respect to x, and that one is normally written this particular way. Y, which is now the one we're looking for, is the integration of 6x with respect to x. And what I'm trying to say, or what I have in inverted commas there, is how we read this part of the function. This function normally read as y is equals to the integration of 6x with respect to x, because we're assuming that the 6x is change in y over change in x for some function y. Therefore, generally, we normally say that an integration of x raised to power n with respect to x is obtained by doing this kind of operation here. And let me explain to break it down so that it looks easier for you. First of all, what we have here is just that this x, which was raised to power n, is now raised to power that n plus 1. In other words, the power of x is raised by 1. You remember when we were differentiating, we were reducing the power of x by 1. We are adding now. And then we are dividing the whole term with the result of that addition there, which is n plus 1. When we were doing differentiation, we were multiplying, but now we are dividing. And then we add a c. I'll show you why we should have the c at the end, somewhere in a few moments. And that one there equals to y, therefore. And that's part of it. The other part of the same is if we are integrating m x raised to power n, and please remember that in this case n, and this n also, and m, they are just numbers like 2, 3, or whatever it is. So integrating m x raised to power n with respect to x, which is what we have on the left hand side there, will be m, this m as it was and as it was placed there, then the x raised to power, the n was a power at the beginning, now we add by 1, therefore it becomes x raised to power n plus 1, and then divide the whole term by the same thing, and of course add an additional c, so we call it mx raised to power n plus 1 all over n divided by n plus 1, then plus c. Now therefore, for the function that we were dealing with, changing y, changing the x is equals to 6x, this one, if we want to look for the value of y, we would be having y is the integration of 6x with respect to x, which is 6x in brackets 1 plus 1. Please remember that the power of x here is 1. So we are adding the power of x from 1 by 1 to x to 1 plus 1, which is of course 2. And therefore, it is x raised to power 1 plus 1 divided by the whole thing, then plus 6 plus c, which is 6x squared all over 2 plus c, and of course simplify to get 3x squared plus c. Now at this point I should mention that whenever you have done integration, you can always reverse, that is differentiate, to see if you get the original thing. Like if you differentiate this, would you get 6x? No doubt you will. Now the next question, therefore, you probably now are asking, so why do we need the c's? At this point I'm going to explain why. Now consider the following. If we're given y is equals to 3x plus 7, y is equals to 3x squared, y is equals to 3x squared minus 10, y is equals to 3x squared plus now all of these terms have 3x squared and then a constant. You see that? Here we have the constant is plus 7. Here the constant is 0. There is no constant, so assume it's 0. Here the constant is negative 10. Here the constant is half. Now, differentiating all of these functions, changing y over changing x would give us 6x. What does that tell you? If we are integrating 6x with respect to x, we should always add our c, because we don't know what kind of constant there was. It could have been plus 7, or no constant at all, or minus 10, or half, or even any other. So we normally put a c to represent whatever constant there was in the function. Yeah, let's continue with particular examples to tie these concepts together. Now, every time please add c. Every time add a c. Now, examples. We have the first one there. We have we're told find y given that y prime is equals to some questions there. Now, let me say that y prime, I said in a previous lesson, is the same as changing y over changing x. Therefore, we are given the gradient, changing y over changing x. Now we're looking for the y. Find y when given the gradient is the first one, 7. We're going to use the rule that I showed you at a few moments ago. And therefore we have y will be integration of 7 with respect to x, which is normally operated by having 7x raised to power 0 plus 1 all over 0 plus 1 plus c. Someone is wondering, where is the c coming from? Sorry, where is the x coming from? I say it this way. 7 is the same as 7x raised to power 0. So there is an x whose power is 0. So we just have it that way, and then we add 1. Okay, so the power of x originally was 0. We add 1, divide by the whole thing. That is 0 plus 1 plus c. And therefore the answer will be y is equal to 7x plus c. If you differentiate this, will you get a 7? No doubt you will. The next question, we have y, changing y or changing x is 2x plus 4. And therefore y will be the integration of 2x plus 4 with respect to x, which is operated this particular way. We had 2x, the power is 1. Therefore we have now 1 plus 1 divided by the whole thing, that is 1 plus 1, plus 4 had an x whose power was 0. So we have now 0 plus 1 divided by 0 plus 1. 0 plus 1, then we plus c. Simplify that, you get y is equal to x squared plus 4x plus c. Differentiate this in here, and see if you get the answer to be 2x plus 4. And another question, x cubed plus, 8x cubed plus all that there. Now, we are integrating this function with respect to x again, and these are the terms. This is how they should appear. The first term was having an x cubed, 8x cubed. Therefore, the power of x increases from 3 by 1. So 3 plus 1 divided by the same thing. The next one, the x was raised to power 2, so we have 2 plus 1 divided by the same thing. The next one, the power of x was 1, so we have add 1, and then you divide by the same thing. The next one, the power of x was 0, so we add 1, which is this one, divided by the same result. And the constants remain, the 8, 3, and 4. 8, 3, and 4. And therefore, also again we add c, and therefore that's what we have there. Going forward, you get the answer is 2x raised to power 4 plus x cubed plus 2x squared plus 3x plus c. If you differentiate this, you get 8x cubed plus 3x squared plus is it 4x? Yes, 4x plus 3. Yeah, the differentiating a constant becomes 0. And therefore, my operation is actually right. The next part we go to is maybe before I go, I need to mention this. This is 4x divided by 2. 1 plus 1 is 2, so that's why I get 2 here. Okay, the same case also, this was 3x, and you're dividing by 3. This is 3 here, so that's why I don't write 3 because 3 cancelled out. Here the 2 cancels out also. And another question is the one on your screen there. Now, getting y, since this is a gradient, would be integration of this function with respect to x, which I have on your screen there. And the terms that will be involved there will be the ones that I've listed for you. The 9x raised to power 3, the 3 you add 1, divide by the same thing. The next one was minus 2x raised to power negative 4, minus 4 plus 1, divide by the same thing. This is an interesting one there. Then we have 3x squared plus 1, divide by the same thing, plus c. Now, the first one, 3 plus 1 is 4, so it becomes x raised to power 4. Then 9, all of it divided by 4. The next one, it is 2x, then we have minus 3. Take care of negatives. They're not very good things. This is negative 3, and then you put it again here. So it becomes negative 3, it's up there also. So you have 3x again raised to power 3 divided by 3, that one there. And then you need to simplify. Notice that this term here becomes positive and it was negative here because it was influenced by the negative index. And again, the 3 cancels the 3 to get just that in there, and so add C, and that's your answer. If you differentiate this, you're going to get this one here, I believe. And so please try that. Another question, we have 13k raised to the power 5th plus 1 over 3k raised to the power 5 plus 8. Integrating that means we are integrating with respect to k. It means that the function y was expressed in terms of k. It was y is equals to 13k something. And what I'm trying to say there is it was differentiation of y with respect to k. So we are now integrating with respect to k. And therefore we get that kind of a thing. I've tried to transform it this way so that it's approachable. The 3k squared means the k raised, so the 3k raised to the power 5 means that the k raised to the power 5, if you bring it up, becomes negative. And so we have it that way. And so it will be easier to operate. And therefore the terms included there would be this ones here. 13k raised to the power 5th, that one there, plus 1. Then divided by 1/5 plus 1. The next one plus k is raised to the power negative 5, so we have k raised to the power negative 5 plus 1 divided by minus 5 plus 1. Please notice there was a 3. That's a 3 here. So you don't need to be worrying where that comes from. There's a mistake here. I need to mention there's a mistake here. This should be 8. Okay? Yeah, please correct that when you're working out the question. This would be 8x raised to the power 0. And therefore the answer will be that one there. So the answer should be 13k raised to the power 6 over 5 divided by 6 over 5 plus k raised to the power negative 4 all over this one, and this is 8x plus c. Simplify further, you get 65. You see, double reciprocal brings a 5 up, so it becomes 13 times 5. 65 over 6 is a k raised to the power 6 over 5 minus, this time round it becomes minus because of this negative 12, alright? Becomes this negative 12 here, so it becomes that one there, and then we have plus. This should be 8x plus c. That's my typing error which I carried forward. I think I did copy and paste, so please take care of that. Let's go to the last set of examples that we look at. We have an interesting one there on your screen. It's a quotient, that is, we have a term divided by something, and therefore we're just integrating that, but you need first of all to transform it. Divide every term by x cubed, like that, like I have written there, and then simplify to get 1 minus 4x raised to the power negative 2 plus 4x raised to the power negative 3. This is an operation that requires your knowledge of indices. I'm not going to get into that. I hope you can always consult or ensure that you understand where these figures come from. But just to mention, the x raised to the power 3 comes up. Therefore, we have 1, the power of x being 1 plus minus 3, which is negative 2. Integrating that will be this kind of a thing here. We have x, that is, sorry, we have 1, then your x here is raised to the power 0, so we have 0 plus 1 divided by the whole thing. Then we have 4x raised to the power negative 2 plus 1, all over negative 2 plus 1 again. 4x raised to the power negative 3 plus 1, negative 3 plus 1 as a denominator plus c. Simplifying that, you get x. All of this one here reduces to x. All of this one here reduces to, what is it? Sorry, all of this one here reduces to 4x raised to the power negative 1. Is that true? Yes. And yeah, it is negative at the bottom there. Then this on the hand here becomes a 4x raised to the power negative 2 all over negative 2 plus c. Simplifying further, this sign here, the sign of this term here reverses to become positive. The sign of, I think the other one reverses to become negative, and that one. So if you differentiate this, will you get this? I think you will get negative 4x raised to the power negative 1. Then we have 4x raised to the power negative 3. Yes, that's actually true, and therefore that is the answer. Another question is this one here. Again, please integrate it, but please understand that these two terms are just written with a little trick. The difference of two squares is kind of observable from the question. If you just exchange the 1 over x with 1, that is, bring this one here and the 1 here, the term looks like the question looks like this. And now we can expand using the knowledge of difference of two squares, which becomes this one, which can be operated using now indices to become this one. Integrate, you get x raised to the power negative 2 plus 1 over negative 2 plus 1 minus x 1 in brackets x raised to the power 0 plus 1 over 0 plus 1 plus c. And therefore the answer will be minus x raised to the power negative 1 plus x minus x, plus c. That's it. Now, as we go forward, I'm going to give you some questions you can try. I'm going also to give you answers. You can always print maybe and see what you try out. For your home self-test, we have these questions. We have this one here. This is a function. Look for y. please it means you'll be integrating this with respect to x, and the answer should be this one. Check out how true it is. You can always try out. The other one is we have this question. That means we are integrating it with respect to x, and therefore your answer will be that one there. Check out if it's true. We have also this question here, which is a little technical, written in terms of t. That means we're having changing y over changing t is this one. So we are integrating with respect to t, and the answer is this one. See if that is true. I hope you like it. Check out for the next lesson that will be coming for the next concepts on integration. I appreciate those people who have subscribed and who share. I'm really grateful. Thank you.